Imagine this problem. There are 4 bodies of land with 7 bridges connecting them. You need to find a route where you would travel on all 7 bridges without crossing any one of them more than once. Sounds easy enough? Pause and try finding some paths. Not too easy, is it? It seems so simple in theory, but this problem is actually impossible to solve. But why is that so? This infamous problem actually led us the way to create an entirely new branch of mathematics called graph theory. Simply put, graph theory is the study of graphs. It's used to model connections and relationships between different entities. But it's not the same type of graph that you would use in algebra. These graphs are made up of nodes, which are the different entities, and edges, which are the relationships between them. Nodes are represented as points, and edges are lines connecting the points. In the previous example, the different bodies of land are the nodes, and the bridges are the edges. You must come to the body of land from one bridge and leave via another, which means that the number of edges connected to each node must be even, except for the first bridge you cross and the last bridge you cross. However, in the problem, every node has an odd number of edges coming into it, which means that it's not possible. Now you may be thinking, so what? Graph theory can solve one random problem. But the concepts of graph theory are actually applicable in so many different aspects of life. Say I want to travel from Seattle to Maine and get there in the least amount of time possible. There are no direct flights, so instead I need to find the shortest path. To solve this problem, we use graph theory. I represent the different airports as nodes and the flights as edges. What I've drawn here is just a simplification of the problem. I can now see that I could go from Seattle to California to New York to Maine, or Seattle to Illinois to Maine, or one of the other hundreds of thousands of possibilities. To make this easier, mathematicians have created algorithms, which are kind of like a set of instructions on how to calculate important properties of graphs quickly. But even with an algorithm, this would take days to do by hand. That's why graph theory is often intersected with computer science, since computers are much faster. As you can see here, I programmed Dijkstra's algorithm, an algorithm that finds the shortest path between nodes. I got data on hundreds of thousands of flights and loaded it into the program, and I can now find that I could get from Seattle to Maine in 336 minutes. This same concept is how Google Maps finds the best route for you to take. Other algorithms are applied when Instagram gives you suggestions on who to follow, or how your school assigns your schedule based on the combination of classes you want to take. Here's a list of just a few of the applications of graph theory. Along with social network scheduling and routing, it's used to give you recommendations, and web search is just graph theory in action. The number of applications of graph theory are endless. Here's just a handful of the countless companies that use graph theory.